Okay, welcome everyone. Thank you for turning into our video lesson for today. Today we're going to go over Unit 6, Lesson 4, Solving Systems of Equations using three methods. We're going to go over three methods on how to solve a system of equations. And you'll notice that your essential question is which method of solving of systems of equations do you prefer? And explain why you prefer this method over the other methods, okay? And the two vocabulary words that you guys should be aware of is what a system of equation is. And a system of equations is a collection of two or more linear equations with the same set of unknowns, meaning the same variables in both equations, okay? And the solution to a system of equations is just the point of intersection between two or more linear equations, okay? So we're only going to be dealing with linear systems of equations. So let's go ahead and start by solving the system you see there by graphing. Now we're going to be solving the exact same system, except we're going to be using three different methods, okay? So here we go. The first thing you want to do when you solve by graphing is, in order to solve these systems by graphing, you want to graph each one of those linear equations on the same graph. So what you're going to do is you're going to have two graphs, okay, or two lines on the same graph. So the easiest way to go about graphing a linear equation is to isolate the y, meaning get the y by itself, and then use the slope and the y-intercept. It's the quickest method. So what I like to do is I like to label my equations so that you know which equation it is that I'm talking about. What I mean by that is I'm going to label them equation 1 and equation 2. So I'm going to go ahead and take equation number 1, and I'm going to isolate the y. So I'm going to go ahead and add 4x to both sides. There we go. And that leaves me with y equals 4x minus 6, in which case my slope is 4, but I like to write it as a fraction of 4 over 1, so you can see the rise and the run. This is your rise, and this is your run. Notice I went up because the 4 is positive, and right because the 1 is positive. Okay? And my y-intercept is 0, comma, negative 6. So I'll go ahead and start by graphing the y-intercept, which is 0, negative 6. So I'm going to go down 1, 2, 3, 4, 5, 6. There we go, right here. There's 0, negative 6. And then from that point, I'm going to go up 4 units, right 1. So up 4 units, 1, 2, 3, 4, up 1, or excuse me, right 1. There you go. And then I'm going to draw a line right through those 2 points. Okay, now you want to make sure you guys draw your lines as accurate as possible. That way, when we are looking for the point of intersection, we get an accurate point of intersection. All right, so let's go ahead and draw our line right through these 2 points, like so. Okay, there we go. All right, so don't forget your arrows on this right and left. All right, with that said, I'm going to now go ahead and graph the other equation. And for the other equation, it's going to be easier to graph this equation using a table of values. By that I mean an XY table. Okay, and you have to be smart about what values you choose for X. That way, you guys don't end up with any fractions as a Y value. We want to try and avoid fractions a little bit just because graphing fractions can be a little bit more difficult. Okay, so I'm going to go ahead and choose values for X such that my Y values ends up being a whole number. Okay, so I'm going to choose the value of 1. There we go. And I'm also going to choose the value of negative 2. Okay, so here we go. You kind of have to look ahead because you know you're going to have to substitute that value in for the X and then move it to the other side and then divide by 3. So you want to make sure that whatever number results when you start getting the y by itself ends up being a number that is divisible, in this case, by 3. Okay, so when x equals 1, 5 times 1, because I replaced the x with the 1, plus 3y equals negative 1. This ends up being 5. 3y equals negative 1. So now I'm going to go ahead and subtract both sides by 5 to get rid of that 5 over there. Makes a 0. I'm left with 3y is equal to negative 6, and if I divide both sides by 3, I end up with y equals negative 2. Okay, so the y value is negative 2, and you see what I mean? I ended up with a y value that is not a fraction, makes it a lot easier to graph. Okay, now I'm going to go ahead and substitute my other x value, which is negative 2, and do the exact same thing. Okay, evaluate this thing, or solve this thing for y, excuse me, when x is negative 2. So this ends up being negative 10 plus 3y equals negative 1. And if I go ahead and add 10 this time to both sides, it leaves me with 3y equals positive 9, and if I divide both sides by 3, I get y equals 3. And there we go. Okay, so now I'm just going to go ahead and plot those 2 points, 1 and negative 2. Okay, I'll do it in a different color here, 1, negative 2, so 1, negative 2. Oh, would you look at that? There we go. Okay, and then negative 2, 3, negative 2 back, up 3. Here we go. And now I'm just going to go ahead and draw my line right through those 2 points. And of course you can tell that the point of intersection is this point right here, okay? That point being 1 comma negative 2, which means that is my solution to this system of equation, 1 comma negative 2. Okay, the point of intersection is what you're looking for. Okay, so with that said, that takes care of the graphing method. Let's go ahead and go over to the substitution method. Okay, and the substitution method is going to require us to solve this exact same system of equations, except we're not going to be using a graph. Okay, we're going to do this algebraically using the substitution method. So I'm going to go ahead and write the substitution, the system of equations here so you guys can see it. There we go. Plus y equals negative 6, that's equation 1, and equation 2 is 5x plus 3y equals negative 1, and there we go. Okay, so in the substitution method, what you want to make sure, or what you want to do first is scan each one of those equations, okay, because what you need to do is you need to decide which variable, either the x or the y, you want to isolate. You want to make it be by itself. And if you look at equation 1, it is much easier, okay? It is much easier to make equation 1 have the y by itself, because all you would have to do is just make sure that you take this negative 4x and move it to the other side, okay? And then the y would be isolated, okay? So I'm going to go ahead and take equation number 1, and I'm going to go ahead and isolate the y. So I'll go ahead and add 4x to both sides. So now I'm left with y equals 4x minus 6. Okay, now I'm going to go ahead and box this equation here real quick. Okay, because I'm going to come back and use that towards the end. Okay, now that I know what y equals 4x minus 6. You have y equals 4x minus 6. What I'm going to do is I'm going to take what y equals, the 4x minus 6, and I'm going to substitute that into the y value in equation number 2. I'm going to take what y equals, meaning this part right here, and I'm going to substitute it right in there. Okay? So my goal is to have one equation with only one type of variable. That way I can solve for that variable. Okay, so I'm going to go ahead and substitute what y equals. In this case, it's the expression 4x minus 6. 4x minus 6. Okay, and you see how I have only one equation with one variable? Okay, only x is all the way across. So now I can go ahead and start solving for the value of x. Distribute here, 12x minus 18 equals negative 1. Combine like terms, that's 17x minus 18 equals negative 1. And if I add 18 to both sides, I get 17 over here. And if I divide both sides by 17, I end up with x equals 1. Okay, so now that I have my x value, I'm still not done. I got to go back and get my y value. Okay, so remember the equation that I manipulated, equation number 1, the one that's in the box? It is easier to go ahead and use that equation to find the value of y because the math will be all on one side. You can go ahead and substitute the x value, this x value here, you can substitute it into equation 1 or equation 2. But if I were you, I would substitute it into this equation because it's a lot easier to substitute it into that equation because the math will be all on one side. So into this equation here, I will substitute this value in for the x right there. Okay, so 4 times 1 minus 6. 4 times 1 is 4 minus 6. Y equals negative 2. Okay, so now I got a y value of negative 2. Okay, so my x value is 1 and my y value is negative 2. And if you recall from our graphing example, you see how the answers are the same? You should get the answers to be the same. You're actually solving the exact same system of equations. Okay, so that's the substitution method. Okay, and now we'll move on to the last method called the elimination method over here. And I'm going to once again write the system of equations so that you guys can see it here real quick. So you're going to have, so we'll have negative 4x plus y equals negative 6. That's equation 1. And equation 2 is 5x plus 3y equals negative 1. Okay, so the way we solve this using elimination is what we're trying to do is eliminate either the x terms or the y terms, okay? By combining those two equations together, by adding them together, okay? So if I go ahead and add them the way they are right now, just go ahead and add them, watch what happens, okay? This would be negative 7, combining those. This would be 4y, and this would be negative x. And you'll see that this equation still has two unknowns, okay? So that didn't help me, okay? So what I want to do is I want to make it so that one of those variables ends up going away, okay? Meaning it gets eliminated when the two equations get added together. And in order to do that, I need to make sure that one of those variables, either the x or the y, doesn't matter which one, okay, has the exact same coefficient, meaning the number in front of the variable. Okay, they need to be the same. This and this need to be the same, but opposite signs. That way they make a 0 and end up going away. But if you'll notice that the y has a 3 and it has a 1 right here in front, the invisible 1 that I've always been talking about all year long, okay, it's going to be easier to make this term here into a negative 3, okay, because I would only have to manipulate one of these equations. So if I want to make this into a negative 3, okay, and this will stay as a positive 3, when I combine these two, it'll make a 0, and it'll eliminate the y terms, okay? So I'm going to take equation number 1, and I'm going to go ahead and multiply equation number 1. Remember, I need the y term in equation number 1 to be a negative 3. So I'm going to multiply the entire thing by negative 3, okay? So I'll go ahead and start distributing here. That's positive 12x. Here, that's negative 3y, which is what I wanted, all the way across, positive 18. Okay, see how the y term is now at negative 3y? Now what I'm going to do is I'm going to take equation number 2 and write it right underneath. And now I'm going to go ahead and combine these two equations. I'm going to add them together. Okay, now watch what happens. Over here I get 17. This makes a 0, so that's just 0. Okay, and this over here made 17x. See how the y's got eliminated? Now, 0 is just nothing, so I will just go ahead and ignore the 0. And now I'm going to solve for x, okay? Divide both sides by 17, and I get x equals 1. And now all of a sudden I got the value of x. Okay, with the value of x now solved for, I'm going to take the value of x and I'm going to choose one of the two equations, one of the two original equations, equation number 1 or equation number 2. Okay, it doesn't matter which one you choose. Usually, if you take a look at them, one of them will seem easier to you than the other one. The numbers aren't too big here, so it doesn't really matter. But I'm going to go ahead and choose equation number 1. And what I'm going to do with that is I'm going to go ahead and substitute the x value, which is 1, right in there. Okay, that way I can solve for y. So substituting the x value of 1 and then solving for y will end up giving me my y value. Okay, moving right along. I'm going to add 4 to both sides. And I'm going to end up with negative 2, which is what I should have gotten because 1 comma negative 2 is the answer to all the other or the other two methods that we ended up using. You see that? Okay. With that said, I have another example for you guys to try. And what I want you to do is pause the video, okay, and go ahead and work this system of equations, work it out, solve it for x and solve it for y using all three methods. Pause the video, and when you're done, go ahead and click play. That way you see what answers you should have gotten, okay, and then that way you can check your work. Okay, this is what you should have gotten for the graphing method on example number 2. You'll notice the point of intersection is at -2, -3, and there is the work right next to it. Okay. All right, moving on to the substitution method. Here is the method for substitution. You'll notice that I isolated the y in equation number 1, and then I substituted what y equaled, in this case the 2x plus 1, into equation number 2. And of course I did get the same answer. And then the elimination method. There's the work for the elimination method. You'll notice that I took equation number 1 and I decided to get rid of the y terms. So I multiplied equation number 1 by -1. And I went ahead and added those two equations together, eliminating the y's, solved for x, and I got a -2. Then I took the -2 and I substituted into equation number 1. I could have substituted into equation number 2, but I chose 1. And then I ended up getting a y value of -3. And of course I got the exact same answer. So thank you for tuning in, and we'll see you on the next lesson.